Hello everyone, I'm Koyan, and can you guess what I'm going to learn today? I believe a lot of students wonder this question. Walao biology learns so many health issues, got sickle cell anemia, haemophilia, and thalassemia, still got anemia. How to actually differentiate them? So yeah, I have specially made this video to clarify what are the differences between them. Yeah, a bit funny, but yeah. So what are differences? So if you can actually picture it, it will be way better compared to you memorize the word straight away. So sickle cell anemia, you see this sickle cell, the red blood cell is crescent shape, or you can say sickle shape. What about hemophilia? Hemophilia is where the person would bleed a lot. Okay, why bleed a lot? Later on you will learn why it will excessive bleeding. And last but not least, thalassemia. You can see from the diagram, it may be low number of red blood cell, but it's actually because of produce low number of hemoglobin. It's not mainly red blood cell, it's to be specific, produce lesser number of hemoglobin because hemoglobin is contained inside the red blood cell. So let's take a look at the differences between them. I have differentiated them the day before SPM and I asked my biology teacher to actually help me check. So it was like few hours before biology SPM. Yeah, my teacher very kind. She helped me check it out and this is already finalized. If you got more opinions, something to add on, you can feel free to comment down in the comment section below. So what are similarities between them? Yeah, all of them are blood cell disorder. And the second similarity is all can be inherited. Yeah, it can be inherited from one generation to the next generation. What about the differences? There's a lot of differences. But will it actually come out? I I don't think I cannot say I don't think. I would say they won't come out seldom, very rare they will come out differences between three of them. Normally they will come out differences between two. One ask you to differentiate between three lah. So this is only for clarification, so for you to learn things like how it makes sense because sometimes they may ask a specific health issue and then they want you to explain this whole thing, so at least you know what are the differences between them in case you thought this is sickle cell anemia and then you end up answering another hemophilia issue or thalassemia issue or you mess up all the points. So yeah, let's move on to straight to the point right here. So sickle cell anemia, as you can see, the word is so obvious that it is sickle cell, means the red blood cell is present in the shape and it is caused by gene mutation. So if you learn in chapter 12 about mutation, got chromosomal mutation, gene mutation. So gene mutation, you got branch out into base substitution, base deletion, and base insertion. So it is categorized in the base substitution, whereby the thymine base is being replaced by adenine. Therefore, what will happen, it will actually produce valine instead of glutamic acid. This is the specific amino acid lah. The amino acid named valine is produced instead of the glutamic acid. This one is the normal case, but the abnormal case is the valine amino acid. Right. What about hemophilia? It is because of presence of recessive allele. Remember what is dominant, what is recessive? Recessive allele always get suppressed by the dominant allele when there's a presence of dominant allele. The effect of recessive allele will be suppressed. But if there is no dominant allele to suppress the effect, yeah, the recessive allele, the effect of it will be shown. So it is the presence of recessive allele in sex chromosome. Most importantly, it is in the sex chromosome. So remember, sex chromosome is in normal situation, 44 plus XY is the male, and then female is XX. So this is the sex chromosome, the one that determines the gender. And yeah, X, small letter HY for male, small double HH, because if it has one big H one small H, yeah, that one, the effect will be suppressed, or maybe it is not very severe for this hemophilia. And what about thalassemia? It is due to gene mutation. So gene mutation on the autosome, whereby to be specific is chromosome 16 or 11. And this an extra info is because of base substitution. Then, but the previous one here got mentioned in the textbook. And what about sex-linked inheritance? Is it a sex-linked inheritance? No, sickle cell anemia is not. Where hemophilia, yeah, it is a sex-linked inheritance since it involving the sex chromosome. Of course, it is a sex-linked inheritance. And thalassemia is actually a not a sex-linked inheritance. I ended up writing it wrongly. I'm so sorry. Alamak. Okay, later I edit. Okay, then okay. Okay, so nothing is perfect because I'm a human. All right. So what are the chances of occurrence in male and female? So for the chances of occurrence in sickle cell anemia is the same. Thalassemia is the same. Why do I mention this uh chances of occurrence thingy? Is because hemophilia, since it is a sex-linked inheritance, the male tend to have higher possibility to have hemophilia. So it's because, right, you need just one X and small h, then you already get the hemophilia. Compared to female, you must have X two recessive allele, then you only get a hemophilia. So that's the reason why for male possibility is higher. Because male, right, sure got one sex chromosome will be Y1 because Y chromosome is the one that determines that that person is a male. So another sex chromosome, it really depends on this one and only whether it is has X capital H or X small h. So it is impossible for male to be a carrier. But for female, yeah, you can be a carrier. You can have one recessive and one dominant, but you may not show the symptoms. So you become a carrier in the end. Alright? And moving on to the next one is the condition. Yeah, sickle cell anemia obviously is sickle cell shaped red blood cell due to defective hemoglobin because the hemoglobin shape is different, and yeah, that's the reason why it affect the shape of the red blood cell. But normally we just remember the crescent shaped red blood cell we do lah. And for this hemophilia, yeah, the person kept bleeding. Why it kept bleeding? Okay, very hard to stop bleeding is because of lacking clotting factor. To be precise, is 8 or 9 lah. But yeah, you want to memorize also can, don't want also can lah. But most importantly, you have to know it is lack of clotting factor. That's why it will lead to excessive bleeding. Meanwhile, for this thalassemia, it's because of abnormal hemoglobin and low number of hemoglobin. So the number of hemoglobin produced very low and the hemoglobin is very abnormal. Yeah, can't really transport oxygen effectively. And what are the effects if you have this crescent red blood cell? Yeah, your red blood cell unable to transport oxygen effectively because supposedly red blood cells should be a biconcave shape, right? That's why you get to increase total surface area. Yeah, for to transport more oxygen. But now it become a sickle cell shape. So yeah, you can see how it affects the total surface area. And other than that, since their shape is sickle cell, is crescent shell, they tend to clump together, and therefore sometimes when they pass through a maybe capillary blood vessel, I mean maybe blood vessel like in general, they have a higher possibility to clump together because of their shape. So eventually it would lead to poor blood circulation. And what about this hemophilia? Yeah, blood unable to clot. That's why the effect is leading to excessive bleeding. That's why you have to say thank you to blood clotting. Okay, whenever you fall down, say thank you to your clotting factor. About the effects of this thalassemia is less production of hemoglobin, hemoglobin produced is normal. That's why it will lead to low transportation of oxygen. So, since the sickle cell anemia, they have a poor blood circulation. Their hemoglobin unable to transport oxygen effectively. Can you guess what happened to your body cell? Your body cell unable to receive sufficient oxygen because you need oxygen for cellular respiration to generate energy, right? But now, lack of oxygen, body cell don't receive enough oxygen, less oxygen used for respiration. So, less energy generated, you are very fatigued, tired, tend to get really tired. And there is swelling in fingers and toes probably because of poor blood circulation and delayed growth because the transportation of the nutrients, all these are slightly disrupted lah. So yeah, because blood not only carries oxygen, it also carries all the essential nutrients like glucose, right? And what about this um hemophilia? Yeah, unusual bleeding, excessive internal and external bleeding. So what is internal bleeding? Can you recall like sometimes you hit something very hard and then the next day, oh, your elbow got a bruise, right? You can see dark in color or maybe green in color like that or blue in color. Yeah, you have a bruise. So the bruise is actually due to your blood vessel inside. It damage blood vessel burst. So blood vessel burst, that one is inside so it's called internal bleeding. External bleeding is outside your injury. You can straight out see the blood flowing out and then, mommy, I fall down like that. Yeah, that one is external bleeding. You can see the blood. But internal bleeding, let's say, oh, you accidentally hit something and then, yeah, due to you hit something and then the blood vessel somehow, yeah, burst already, yeah, that one is lead to internal bleeding. And the clotting factor will actually do blood clotting to quickly, prevent excessive internal bleeding. But because of hemophilia, yeah, the blood lack of clotting factor, that's why it leads to excessive internal bleeding. Although you can't see it, the effect will be severe if there is an excessive internal bleeding. And what about this thalassemia? Yeah, due to low transportation of oxygen, same kind of similar explanation lah. Body cell didn't get sufficient oxygen, not enough oxygen, less oxygen used for the cellular respiration, less energy will be generated. That's the reason why it tends to be fatigue, slow growth, and one of the characteristic is facial bone deformities. If you search online, yeah, you actually see that the person actually have a facial bone deformities. And what is the treatment for these three? For sickle cell anemia, um since this is a gene mutation, but normally lah we would do a bone marrow transplant. Same goes to thalassemia. The effective way is to use bone marrow transplant, probably from siblings lah. And what about hemophilia is to inject the clotting factor. So if you can recall chapter 13, we learned the using recombinant DNA technology to produce goat milk that consists of a clotting factor. Yeah, it is to treat this hemophilia patient. So when they drink the goat milk containing clotting factor, yeah, it will make it less severe lah, but it's not a permanent treatment lah. Okay, so that one is drink goat milk. Sorry, inject clotting factor is, yeah, they will synthesize the clotting factors in the lab and they will inject to them. Uh, maybe I can't I can't be specific in this, but yeah, probably uh, in some period of time, they have to go for this injection of clotting factor. So some students might wonder, like, since this one is gene mutation, what about gene therapy? Is it possible since sickle cell anemia and thalassemia is due to gene mutation? Can we actually use gene therapy? Well, I think so. Yeah, probably can lah. But for now, there is technology, the research and development, they are currently doing it. But for now, most of the cases, they will just use bone marrow transplant because why use bone marrow? Cannot use, you know, yeah, they actually use blood donation. Sometimes your blood donation is go to these people. Yeah. So bone marrow transplant, the reason why is because bone marrow consists of stem cell. So stem cell is the cell that is undifferentiated, and the cell will get differentiated into a specialized cell. Yeah, let me rephrase my sentence. The cell will be, it is still undifferentiated. So, yeah, it will differentiate it into a specialized cell to perform a specific function. So, bone marrow, to be specific, lah, stem cell got pluripotent, multipotent, totipotent is the multipotent one. Lah. So, yeah, it will differentiate into this red blood cell. So, that's the reason why bone marrow transplant is effective for the treatment. But also have to consider some risks. So, lah, sometimes it may reject, it really depends on the situation. And what about anemia is something I would like to add on. Anemia is actually due to lack of healthy red blood cell and low hemoglobin lah. So normally it's due to the deficiency of iron and vitamin B12. So if your nutritional intake, your eating habits, you eat less food that contains rich in iron, vitamins, B12 in specific, yeah, you may have anemia lah. Then it is not inherited, not like these three, whereby they will be inherited. And then the symptoms is also fatigue lah. Since all these are actually related to red blood cell plays a very vital role on transporting oxygen lah. So yeah, I guess that's all for this chapter. This chapter pula. This topic. Okay, and I'll see you in the next video. Bye bye.